Okay, good morning, everyone. Sounds like the mic is on. You can hear me okay in the back? Okay. So, good morning. My name is Matt Reuter. I'm guessing you're all here for AMS 103, Applied Math and Modern Technology. If not, one of the two of us is in the wrong place. And the way this year's been going for me, it could very well be me, but I don't think it is. Okay? So, a couple things. First of all, welcome. If you're new to Stony Brook, welcome, and I'm glad you're here. If you're returning for another semester at Stony Brook, welcome back. I'm still glad you're here. Couple things. First of all, as I said, my name's Matt Reuter. I really don't care what you call me. Dr. Reuter is fine. Professor Reuter is fine. Matt is fine. I would probably prefer that. The one that does sort of get on my nerves is Mr. Reuter. I don't teach high school. Okay, but otherwise, like I said, there's that. As we're going through the course, anytime, feel free to stop me. As we're going through the material today, raise your hand, shout at me. If for whatever reason I have my back to you, throw something at me, that's fine. Just if I'm wearing something light colored, please no tomatoes. It's okay to laugh at the jokes. I know it's early. Okay. So what I want to do today is start off by going over the syllabus and sort of describing what this course is, maybe what this course isn't. And taking any questions that you might have. And then we'll do a few other things. I don't believe we'll go the full hour and a half today. We'll start the first real unit next time on Thursday. A few other things just to note. My office hours will regularly be right after class. So I'll have them from 10 to 11:15. Again, knowing that we go till 9:50, it might be like 10:03 because it does actually take a few minutes to walk to my office, and sometimes I like to go to the bathroom after lecturing for 80 minutes. But we'll have office hours right afterwards. My office is IACS L155. How many of you know where the IACS building is? Okay, that's about what I expected. How many of you know where Life Sciences is? Okay, it's the building just west of Life Sciences. There's sort of that small one-story, two-story building just west of Life Sciences. It's in there. If you go out the south entrance of Humanities, just sort of go south a little bit, you can't miss it. Okay, but that's where my office is. And you're welcome to stop by during office hours anytime. You don't need an appointment. Those times are there for you and for your questions. Whether they be related to the course, related to other topics, related to life at college, I'm here to help you. Please, come see me. As you know, the course times, we meet Tuesday and Thursday mornings from 8:30 to 9:50 in this room. There is no textbook for this course. We'll talk about that here in a little bit. And the prerequisite is level 3 or higher on the math placement exam. Helping me, as you look around, you'll notice that there are more than 4 students enrolled in this class. I'm guessing that will still be true after this period. But that means that I alone am not going to be helping you learn the material and provide feedback to you. That's just more than I would be able to cover. We've got about 115 or so students enrolled this semester. So we have a wonderful team of people here to help me. Up in the back corner is David Kramer, who will be our graduate TA to assist with the course. He'll be here as a secondary point of contact along with me to handle all of your questions. And he will be predominantly responsible for grading the quizzes, we'll talk about that in a moment, and helping with some of the term paper issues and whatnot. We also have 4 outstanding undergrad TAs. Some of them are here. I'm not sure if all of them are. We have Marissa Fink, if you're here. Yep, down in the front. We've got, I know Margaret Hartofelis is here. We've got Razia Khan, who I don't believe was able to be here. And is Zhongling here? I don't think so. Anyway, again, on the syllabus, we've got all of their contact information, all of their emails, their office hours as well, which we have purposefully staggered throughout the week. That way, if at any time you've got questions about the material, someone should be available within a day to be able to answer those questions for you. And for all of the TAs, the office hours will take place in Harriman 132, which is the AMS help room over in Harriman, a little bit west of here. Okay? Any questions so far? All right. So for course description and learning objectives, basically, Applied Math and Modern Technology. That is a very nebulous title for the class, which is sort of a hard thing and sort of a great thing at the same time. It's hard because it doesn't really tell you much. And it's hard for me because it doesn't really tell me much either. But what this means, we can talk about a lot of things. And we can have a lot of fun. You know, this class isn't a prerequisite for anything that comes. So we can take our time as we're going through topics. If there's something you really like, let me know that you're really having fun with this. And I can certainly cook up something to do, and we can spend a little bit more time on it. If there's something you want to see covered, let me know. maybe we can squeeze it in. We're not in any hurry to get through this material. We've got no end goal we have to be at. We're here to have some fun and talk about lots of things, various technologies, and how we can use unsophisticated mathematical tools. When I say unsophisticated, I mean basically high school level math. We are not going to see calculus in this class. We might mention the C word every now and then, but we're not going to spend a lot of time on it. We're not going to see big linear algebra. We're not going to see pages and pages and pages of big equations. So just keep that in mind. But we'll look at that and how all that applies back into these technologies. And so I know a lot of you are here because this course does meet 2 SBC requirements. It's got the tech requirement and the QPS requirement. And so naturally, a lot of the themes that we're going to see is sort of looking at what is a technology and how do we understand it? How do we use it? What's some context for the technology? What's its history? Are there societal, legal, ethical, moral implications associated with it? If we're truly to understand the technology and its uses, we can't be ignorant of any of those issues. Naturally, we're not going to talk about every one of them for a given technology, but we'll talk about some. Once we do that, we can usually start to frame a way and start to develop how do we understand this technology? How do we use it? What are some of the inherent issues with it? And from that, we can launch into some of the math parts and start to do a little bit of quantitative problem solving, where we will see some equations. We will see some numbers. We're going to see some graphs. We're going to see some schematics. And we're going to look at analyzing data in a way that's related to some of those ideas with the technology. And then we can bring it all back together. And that's going to be sort of the theme. So I'm not going to read for you word for word this course description and learning objectives, but that's sort of what the structure is going to be and where we're headed. Where some of the objectives and the outcomes are that you are better able to understand technology and think about the framework and understand, again, some of these societal values. Where did this technology come from? That you can apply quantitative skills, whether that's critical thinking, whether that's problem solving, whether that's actually working with some equations or some graphs, but you can apply those skills to understand problems related to the technology and bring it all together. Any questions on that? That's what you should expect and what I hope you will take away from the course. Okay, if no questions, then moving on. So policies. So I know it's early in the morning, but one of the policies is I expect that you're attending lecture. One of the good news or good things about not having a textbook is that it doesn't cost you any money. One of the bad things is that means there's not really a safety net. If things start to get confusing or you think things get hard, there's not something else for you to fall back on. There's not that extra resource. So I'm expecting that you're coming to lecture because this is the primary way for me to communicate with you what the material is going to be. There will be supplemental materials posted. I will post lecture slides after lecture for you. But I'm expecting that by and large you're coming to lecture and you're here participating. I know there's 100 or so students, but I like to be very conversant with you. I like to stop and ask questions. I want you to think. Okay? I can talk to a wall at home and not have to be here this early in the morning. It's really boring. If you don't believe me, try it sometime. Okay? So I expect you're here. Along those lines, attendance may be taken unannounced if I deem it necessary. So if I get here one morning and notice there's 5 people here, guess what's going to happen? We're having attendance. Okay? Some mornings, maybe I get here and there's 100 of you here. Maybe we're still going to take attendance because I still want to know who are the 15 that weren't here. Okay? Attendance will not directly factor into your grade. We'll get to that in a moment here. But on occasion, I might take it. All right? Other policies, I think it goes without saying, please silence your phone and other electronic devices before lecture. When lots of things are beeping and going off, it's confusing to you, it's confusing and distracting to your other classmates, and it's distracting to me. So please keep that in mind. And then the last thing, and I put this part in bold print, extra credit will not be given, don't ask. Okay? I think you'll find as we go through this semester and how we've got things structured, there's lots of regular credit readily available. This is the 5th time I've taught this course. My experience is people who do the regular credit don't need the extra credit. Okay? So that's sort of where we're at. Other policies sort of just for information dissemination. The primary ways that I will contact you are, number 1, through lecture. So certainly key information will be communicated during class. On occasion or for various things, we will also use email to your Stony Brook email account and also Blackboard. Announcements we post on Blackboard, homework assignments on Blackboard, lecture notes, all of those types of things. You are responsible for checking them regularly. And we are not responsible if you don't check it and miss a message and miss a deadline. That's on you. Okay? So things that will be regularly posted to Blackboard, as I said, the syllabus is already there. If we need to update it for whatever reason, I will post an updated version and let you know that that's happened. Slides from lecture will be posted, but only after lecture. I think there's a lot of really good merit in having you take your own notes and having you listening and being engaged. We're not going to go at a clipping pace in this class. But I don't want you sitting there and sort of fumbling with the notes, and I want you thinking during class, and I'll give you the notes later. Okay, but they will be posted. If sometimes days get a little bit busy for me, if it gets to be, like 5 o'clock the day of a lecture and I haven't posted the notes, just shoot me an email, because that just means I forgot. Okay, it's not like I'm trying to deliberately not give it to you. I just had a crazy day and forgot to do it. But they'll be posted. For various units, there will be supplemental readings, which could be either links to other websites. Sometimes I'll actually include the reading itself if it's behind like a paywall or something like that. Will be posted to Blackboard. And then homework assignments and other information on assignments will be primarily distributed through Blackboard. Again, any questions so far? Okay. Now, for the information that you probably want to know the most, how will you be graded? So there are basically 4 components to this class that are going to contribute directly to your final grade. One is homework assignments. We're going to have about 7 units as we go throughout the term. Every unit will have a homework assignment associated with it. Historically speaking, and I don't know, maybe the undergrad TAs can back me up on this, I don't think the homeworks are particularly long or complicated. So we will have one on average about every other week. Some of the units are a little bit shorter, some of the units are a little bit longer, so it'll fluctuate a little bit. I think the homework's usually, probably maybe about 3 hours, 4 maybe, something. So these are not meant to be like incredibly long assignments, but they are intended to make you think. Okay? There will be some easy questions, there will be some more challenging questions, because I want to see how are you processing this material and how can you apply it to things. Because we're looking at some of these math concepts, how do they apply to technology? Okay, so there will be sort of various levels in the homework, but we'll talk about that more when we get to the first homework assignment. There will also be quizzes throughout the semester. Basically, as there's one homework per unit, there will be one quiz per unit. The units largely don't build on themselves. They do very weekly, but I don't think exams are particularly useful in this class, because if we have sort of 1 or 2 exams, they turn into Trivial Pursuit contests, because every unit is sort of just independent. So we're just going to have the short quiz at the end of every unit, and that way you know exactly sort of what's on it, it's done, we move on to the next thing. I've found that tends to work better than having exams in my experience. Notice that it does say quiz and exam. There will be a final exam at the end of the term. We'll come back and talk about this more when we get there on the syllabus. It is an optional exam. Okay? So that is, if you don't want to take the final, guess what? Don't take it. Okay? We'll talk about that more in a minute. But the quizzes and exam will count towards 50% of your grade. And the remaining 35% will be a term paper. Okay? And we'll talk about that more. You'll notice it's actually 2 line items up there in the text. We'll talk about what that means here in a moment. We'll have a lot more to say about the term paper in about 2 weeks. We're not going to spend a lot of time today on it. Regarding how these numbers get translated to letter grades, I do not necessarily use straight scale grading. So at no time this semester should you think a 90 is an A, an 80 is a B, a 70 is a C. That may be how it ends up working out at the end of the semester. I wouldn't count on it. What I do expect is that the median score will be a B. Okay? So I like to write homework assignments that are going to challenge you in ways and give me some feedback on how well are you learning this material. I do the same thing with quizzes, and I don't necessarily want to have to keep in mind, oh, well, is this quiz, at the right level where the average score is necessarily an 85 to try to balance all of those things out. I don't have time for that. So if the scores are a little bit low, I'll show you on Blackboard what the statistics are. Keep in mind the median score will probably be a B when we get to the end of the semester. This is a big enough class where there are good statistics. If that changes, I will let you know as soon as I reach that determination. What are things that might influence that determination? If I keep having to take attendance because there are 10 people in lecture, guess what's probably going to happen? Grading scale's probably going down a little bit, okay? Because that shows me you're not taking this seriously. But if everyone's showing up and everyone's participating and everyone's doing a really good job, look, I realize this is a 100 level SBC course. I get that. I know my place in the universe. I ask you that you show up and you try, okay? If I think everyone's making a good effort, might I be a little bit more friendly at the end of the term? It could happen. There's one way for you to find out. That was a challenge. Okay? So keep in mind, that's sort of what I have in grading. So participation in class, review sessions if we have any, office hours, attendance are all things that are sort of going to influence that decision as we get towards the end of the term. But keep that in mind. Again, we're not using straight scale grading. Do not think 90 is an A, 80 is a B. Like I said, that may be how it works out, but that would be complete serendipity. Okay? So homework, just to discuss, any questions on sort of that total structure before we sort of go through each of those line items in a little bit of detail? Okay, so homework, as I said, there's going to be about one homework assignment per unit. Typically, I will try to post the homework around the beginning of the unit, maybe sort of the first lecture, second lecture or so, and that it's usually due the lecture after we finish the unit. Okay, so that gives you, at the shortest unit, a week to do the assignment. In the longer cases, maybe 2, even 3 weeks to do it. Lots of time for you to look it over, bring your questions to class, bring your questions to office hours, and get them addressed. And so what I will say, though, is homework will be graded for both completion and for accuracy. So for completion, did you make a good faith effort at doing the homework? And generally speaking, what I've used in the past is that's 50% of your homework grade. So did you put in a good faith effort? Doesn't matter whether your answer is correct or completely flamingly wrong. Did you put in a good faith effort? I'll give you 50% credit for that. Other 50%, okay, now we gotta have something that's correct, okay, or at least looking like something that's correct. But that's fine. That's how it's graded. The other thing that I put in here, I am a stickler on deadlines. I will tell you this on day one. Late homework will not be accepted, not even for partial credit. It's got to be due when we say it's due. I'm going to we'll have a survey here in a little bit to get your preference in terms of when you think you want homework deadlines. I'll go with whatever you as the class want. The two options being basically having it due at the start of class, so whatever day it's due at 8:30 when we start class, or having it due at like 4 p.m. the night before. You don't have to, we're not going to take a vote here. I've got the survey, it's a question in there. So let me know what you want the choice to be, and that's what we'll do it. And we can have it due the night before because homework will be submitted through Blackboard. Okay, you're not going to turn in hard copies to me during the semester. When it comes to us grading, when there's 115 of you and there's like 6 of us on the grading team, if we have to hand around the stack of assignments, it's going to take 5 weeks to return any one of them to you, versus when everything's submitted online, all of the TAs can be working, they can look at it simultaneously, they can be working asynchronously, and we can usually get the homework returned to you in about a week. I think it helps us because then there's absolutely no chance that we lose an assignment. It helps you because we can get things returned faster, and I don't see a downside to doing that. What that means, though, is when you submit, Blackboard will put a timestamp on your submission. I have a very simple policy for determining if homework is late. Anybody want to guess what that is? Did Blackboard mark it late? Blackboard marks it late, it's late. Okay? What I will do is we'll say, let's say homework is due at 8:30 a.m. I will put on Blackboard a 5-minute grace window. So Blackboard would end up saying it's due at 8:35. Okay? So if there are sort of computer issues or you're uploading right at 8:29 and something hits a snag, there's a 5-minute grace period before Blackboard marks it late. But at 8:35:00, Blackboard will mark it late, okay? And so building on this a little bit, homework will be submitted, as I said, through Blackboard as a single PDF file. We'll talk about why PDF when we get into our second unit here in a couple weeks. If you're not familiar with making PDF files, there are several resources around campus that can help you. There's also this wonderful resource called Google. Okay? If you do not need to typeset homework assignments, if you want to handwrite them, there are scanners around campus that can turn them into PDF files and email them to you. There are plenty in the library. There are some in Javits. They're all around. There are lots of apps for your cell phone. A lot of people have used one called Cam Scanner in previous semesters. It does a really good job. If you wish to typeset your homework, that is your prerogative. I certainly won't say no because then they're easy to read. Most applications like Microsoft Word and things have options to export files as PDF. For specific instructions, again, I recommend Google. But homework will be a single PDF file. So all of your solutions in one PDF file, upload it to Blackboard, hit submit, done. Okay? Anyway, so you can read about the other things. Regarding how to work on homework, I absolutely encourage you to work with other students in the class. I think there's quite a bit of pedagogical value when you talk concepts over with other people, whether it be with me, whether it be with the TAs, whether it be with other classmates. I think that's a great way for you to learn things, because another person's going to see the problem differently than you do, and you're going to learn from each other. So I absolutely encourage that. What I do request, and when I say request, expect, number one, if you work with other people, you have to tell me who you worked with. On the top of your homework assignment, you just say, I worked with Bob Smith. And then likewise, Bob Smith says he worked with you. Okay? That's fine. Other expectation is everybody writes up their own solutions. I don't care if you're discussing it. Like I said, I actually would encourage that, but everyone writes their own up independently. If the two of you work together, we don't get the same document submitted twice under two names. Bad things will happen if that happens. Which brings us to the bold point at the bottom of this paragraph. Any failure to follow these rules will be interpreted as academic dishonesty and will be referred to the academic judiciary. I have absolutely no qualms submitting people to judiciary. I don't know what the figure was for last fall, but last spring I was 33% of the cases before the College of Engineering. Keep that in mind. Okay? I like to joke around. I like to have a good time during lecture. I don't joke on this. Do not cheat. You know what you should do. You know what the rules are. Follow them. We'll get along fine. Okay? Any questions on homework? Again, we'll have more to say when the first homework gets posted, possibly later this week, most likely early next week. Any questions so far? Yes? So you can assume that help given by me or one of the TAs, you do not necessarily have to cite or say you work with us. That's just you came, you asked a question, and we helped you through it. I'm looking more for when you're working with each other. Yep? So if you're going to use outside resources, you should absolutely cite them. I'm not a stickler when it comes to the format used for it. You absolutely need to cite outside sources, but I recognize this is a very broad class where there's a lot of people from different backgrounds. Some fields like MLA, some fields like APS, some fields like their own different style of citation, so I'm not particularly picky when it comes to which one, other than once you choose one, use it. We'll talk a lot more about that in about 2 weeks. When we start talking about the term paper, we'll spend a bit of time talking about exactly that issue. Thank you for asking. Other questions? Okay. Then if not, as we said, we'll talk about like the quizzes then. There will be a quiz basically corresponding to each homework assignment. So let's say we finish the unit and lecture on a Tuesday. The homework would be due either like that Wednesday night or that Thursday, depending on what you opt. The quiz would be the next class period on Tuesday. Solutions to homework assignments will be posted obviously after the homework is due, for you to look at, post questions about, and get them answered before the quiz. We'll have the quiz then, like I said, about 1 week after we finish the unit in class. The quizzes will, generally speaking, occur at the end of class, so they'll start around 9:30-ish, for those of you that might only want to selectively come to class at times. If it won't be at the end of class, I will announce beforehand for whatever reason that we have to have it like at the beginning of class or in the middle or whatever the case may be. Dates of quizzes will be announced in advance. Typically, when I post the homework assignment, it'll show here's the homework deadline, here's when the quiz will be. There are no pop quizzes in that sense. I'm not going to spring them on you. I don't particularly care for that. And the quizzes will last about 15 minutes, which is to say I'll give you 15 minutes experience from, again, past semesters. Most people don't need more than about 8, but I'll give you 15. That's totally fine. And the quizzes, you'll see problems that are fairly similar to the homework. The quizzes will also put a little bit more of an emphasis on the conceptual understanding rather than necessarily doing calculations, because I know some people are a little bit slower at doing computations and using calculators. And when you have a week to work on the homework, that's fine, but when you have 15 minutes on a quiz, that's not necessarily the best way to assess how well are you learning and assimilating this material. Okay? Any questions on that? I'm sure there will be more when we get closer to the first quiz. Okay? Then the other thing, as I mentioned, there will be a final exam. It is optional. It will be during finals period, and will be scheduled by the registrar. When I checked the calendar last week, the final exam for this class is literally the second final exam on the first day of finals at like 10:30, whatever that time vector is. Past experience, registrar can change its mind They will confirm with me when we get to about April 15th what the date is. I will then put it on Blackboard and let you know exactly what they've told us the time is, but they could change that. As I said, the final is optional. What it's really designed to be is sort of a second chance exam. Okay, so let's say you come, you take the quizzes, and you just had a really bad day on some of the quizzes, or your alarm didn't go off that morning and you overslept one of them, and you think, you know, that quiz score is not reflective of your mastery of the material. That's fine. Come and show me on the final exam that that was a fluke. Okay, that's what the final is designed for. So when we get to the end, if you think your quiz score has been really great and you've been rocking it, and you don't want to take the final, more power to you. Good luck studying on your other exams. Okay, but that's the intent. And again, we'll have a lot more to say about the final when we get to the end of the semester. But does that make sense and seem reasonable? Because I realize, like, the homework, you've got lots of time to work on and get questions answered. The term paper, you've got lots of time to work on and get questions answered. The quizzes, you're sort of put on the spot. You will come here, you don't know what it's going to be, and you've got 15 minutes. So here's the second chance. If you had some bad days, okay, that can happen. Let's not make a habit of it, but show me on the final exam that they were just bad days. Okay? All right, questions on quizzes or the exam? All right, if not, then we'll say just very briefly about the term paper here. Again, we will talk a lot more about the term paper in about 2 weeks. This is not designed to be a particularly long term paper. We're looking for about 3 to 4 pages. And basically what it's going to do is emulate any one of the units that we're going to see throughout the term. So we'll talk about the term paper when we get to the end of the first unit. It's marked in the syllabus. We'll get to the calendar here in a little bit. I think it's 2 weeks from today. When you've gone through the first unit, you can see sort of how we approach taking technology, linking it to some of the math, and doing some problem solving. And the idea of the term paper is you're going to pick a technology of your choice, something that's of interest to you. And you're going to do basically the same thing in the term paper. Talk about what is that technology and what are some of its issues, whether societal, legal, ethical, historical. And then how can some unsophisticated math concepts be used to help understand and use that technology? Very similar to what we had in class. A couple of the key things for this term paper is that, number one, your choice of topic cannot be one of the technologies that we cover in lecture. I do not want you spoon-feeding me back what I gave you. That sort of defeats the purpose of the assignment. And so along those lines, if we scroll back up here to sort of how this grade structure worked, you'll notice that there's sort of 2 line items for the term paper. There's one called process and revisions. There are several milestones as we go throughout the semester that I'm going to be expecting you to do to make sure you're sort of on track to get the term paper done. One of them will be, when we get there in a few weeks, submitting your choice of technology. Because then I'm going to read those through and give you some feedback. Either say, that's something that's a little bit too close to what we do in lecture, please choose something else. Or there are certain technologies that from experience have proven to be very difficult to fulfill the aims and the objectives of the term paper assignment. If you happen to choose one of those, I will probably try to ward you off it and explain why this has not necessarily been a good. It could be a fantastic technology, but it's one that has not worked well in the past, and I might encourage you to pick something else, just that you don't spend a lot of time for something that's going to have a really hard time meeting the objectives of the assignment. Okay? That's the first milestone. The second one, which will be a little bit after spring break, is that you will turn in a first draft of the term paper. We're going to go through a round of peer review on here, so you're going to turn in a first draft, and you're then going to be assigned, when that deadline comes, 4 of your peers' papers to review. You'll have about a week then to go through their 4 papers and provide some constructive feedback. The idea being, sometimes when you see what other people did, it might give you some ideas on what you think your paper was doing really well, or maybe what your paper could improve upon. And I think as in a sort of a functioning society, it's very good to be able to provide constructive criticism. Okay? And so we're going to practice that in this class and work on some of those communication skills to identify what other people do and how can we make constructive criticisms and suggestions about what they can improve. After that peer review is closed, you'll get the comments from the 4 people that reviewed your paper. You'll have a little bit of time if you want to make any revisions to your paper, and then you'll submit the final draft to us, which will then be graded by me and the TAs. And so all of those intermediate milestones go into this 15% for that term paper process and revisions, and then the final draft that you turn in at the end is the 20% line item. Again, that's sort of just the brief overview of the term paper. We'll have a lot more to say about that in a few weeks. But any questions very briefly? Yes? So are there other resources besides the TAs, me, and the material posted on Blackboard? Not really. I mean, there will be some supplemental readings, and some of them will just be websites to other links. There will be that, but again, that's posted on Blackboard. Not necessarily. And so for like the term paper, you're going to have to go find other resources. Again, Google is a wonderful, wonderful thing. We have a whole bunch of librarians over in Melville. If you've never talked to them, they're really friendly, and they're really good at helping you find information. And so that might be something to sort of work on during the course, is how do we do that as well. And that is certainly one of the learning objectives of that term paper assignment. Other questions? Okay, to all of you standing in the front, you know there are seats sort of down here in the scary front rows. I realize it's early in the morning and I'm the professor and I bite. No groans at that? Ugh. You need to wake up. Okay. So I'll let you read the statement on regrade requests. So some of the standard statements here, if you have a disability of any form, please reach out to me and let me know. Anything you tell me will be kept confidential, and we will find accommodations to make sure that you can succeed. So please just let me know. As I've already said, I take academic integrity very, very seriously. If you have questions about what is or what isn't academic integrity, please come and talk to me. I would be happy to have that discussion with you. An ounce of prevention is much, much better than a pound of cure. Okay? Critical incident management, don't do things you shouldn't be doing. And then for student technology services, because we're going to be using Blackboard quite extensively during this term for posting assignments, turning in homeworks, giving you feedback, if you run into Blackboard issues, my experience is at least once this semester on the day homework is going to be due, Blackboard is going to fart. It happens. If it happens, we'll deal with it. Okay? You have that promise from me. We will be reasonable and accommodating in those cases. But if there are issues, number one, please let me know so that I know there are issues. Usually, as soon as I get that, I will post a message to Blackboard saying, I'm aware there are issues. We will reevaluate the situation as it develops, which is code word for stop emailing me about it. Okay? There are 115 of you, and this is my smaller class. So think about what my email inbox is when everyone sends me a message. I need to know these things. It's important, but once I'm... Okay. What you should also do if there are issues is you need to contact someone at Blackboard. I do not have an all-powerful Blackboard fix-it stick. I wish I did. Believe me, it would make my life a lot easier. But you need to let them know there's a problem as well. And their contact information is given here on the slide. They've got, it's helpme@stonybrook.edu. You can also call them. There's a website. There are people at sync sites that can help with some of these issues, but to let them know that there's a problem as well. Okay? So there's all that. So then for the actual schedule, on the very last page, we've got sort of the overview of how this is all going to go down. You can see the different units and then just sort of the ellipses, just indicating we're going to continue that unit. So our first unit that will start next time on the global positioning system is going to take about 4 lectures, in my experience, to get through. Sometimes the days might be broken up, or maybe we finish one unit, we're going to go ahead and start the unit. So there's maybe like usually about 1 day fluctuation in here, just sort of as we go throughout the term. If there need to be massive changes to this, we'll post something in writing. Things to keep in mind, we've got the term paper milestones, at least the dates tentatively listed here in the syllabus, so you might mark some of those things down. Remember that in the middle of March, there's spring break. You are more than welcome to show up here. The room will be locked, and I will not be here. But you are more than welcome to show up. More power to you. And then down at the end, there's at least what the exam is presently scheduled for, which was this 11:15 slot on the 8th of May. But again, that might change, and we'll talk more about that when time gets closer. So, does anybody have any questions about anything there on the syllabus before we move on to other things? Yes?
So a quiz would be how many questions?
Quizzes are typically about 3 questions.
Okay.
Yep. Like I said, they're not designed to be long. They're not designed to be particularly hard. They're not designed to be tricky. There usually seems to be about 1 question per semester where I underestimate its trickiness, and we'll deal with it. That's certainly not my intent. And that's about right from last term. There was about that 1 question where I completely stumbled out the gate, but the rest of them were fine. And we'll deal with it when that happens. Other questions? Yes? So calculators on quizzes are fine. I think calculators on homework assignments are fine, and we'll talk about some other tools, at least for the homework assignments, as we sort of move through the different units. The one restriction on the quizzes, though, is the calculator cannot have Wi-Fi or phone capabilities. So like the calculator app on your phone, no. Needs to be a bona fide calculator. TI-84 would be fine. Most of the quizzes, you probably won't need it. But certainly you're welcome to have one. And one calculator per person. You don't get to like share the calculator with your neighbor. That's a bad thing. You laugh, that's happened before. Okay, other questions? All right, so the one other thing, just to talk about very briefly, is how to communicate with me if you have issues or questions or whatever. Certainly email is a viable option, and for any personal issues or things specific to you, that's the best strategy. If you have a general question about anything we discuss in lecture, some of the material, about a homework problem, or you're looking for hints, or what's the format for the quiz, or something like this, please, 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 please do not generally email those to me. Instead, what we have is this discussion board on Blackboard. So if you come on Blackboard, I know your interface looks a little bit different than mine, but there's this discussions item, and you might notice that we've got a whole bunch of different forums here, one for just general questions, one for the term paper, and then one for each of the units that we're going to go through. Please post your question there. This benefits everyone. Number one, it is quite possible that maybe the question you have has already been asked and answered. So you can get literally an instantaneous response, okay, because it's already there. Number two, it is quite possible when you go to contact an instructor, do you ever email and carbon copy all of the TAs, or do you just send it only to the instructor? No, I'm just curious. I know the answer to this question. You only email the instructor. Is it possible one of the TAs could actually respond quicker if the instructor's teaching another class or otherwise set of meetings? Yes. So the idea of the Blackboard discussion forum is everyone can see it. So all of the TAs and myself will be monitoring it. It's possible they will be able to respond faster than I do. So you can get a response faster. As I said, it's possible your question's already been asked and answered. And from my perspective, this means I only have to answer each question once. I don't have to get the same question from all 115 of you and then have to make sure, did I give everyone the same response? Did I, okay. So this benefits literally everyone. Please make use of this Blackboard discussion panels when you have questions. They're set up for you, and that's what they're there for. What I would recommend doing after class today, if you click on one of these forums, mine already says unsubscribe here. Yours would probably say subscribe right now. What that'll do is if you subscribe to each of those forums, anytime someone makes a post there, you'll get an email message. That way you don't have to constantly log in and check, did someone post something? It'll just email you, oh, someone posted something, and you can log in and see what the discussion is. But please, 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 please use those for sort of general questions that aren't directed like specifically to your personal situation. Again, if you do have a personal issue, please email me. That's not a problem. And office hours are also always a great way to get help. Okay? So does anybody have any questions about that? Okay? Then if not, what I would like to do is to sort of just get the ball rolling today. We're not going to start our first unit. We're going to do sort of a little brief mini intro unit today. And spend maybe about 20, 25 minutes going through that. So the other thing that you'll notice is in the Documents tab, there will be a folder for every unit. You might notice in my interface that the GPS folder is already created. You can't see it yet. We'll fix that in a little bit. But there's this one here for what is applied mathematics. And if you click in there, you'll notice, actually, before we do this, there's one other thing I was just reminded of here. This room is echo recording equipped. I do have it configured to automatically record every lecture and post them in the Echo Center. So you can click there, like if you're sick one day or something and you miss a lecture, the video will be there. Now, there's no guarantee. Again, my experience is about once, maybe twice per semester, the system will have an issue and you will get only the audio, or you'll get only the video of me roaming around here at the front of the room, or you'll get only what's on the computer. But generally speaking, it works pretty well. Okay? These echo recordings are not meant to mean you don't have to come to lecture, but they're meant if you want to go back and replay something, like I said, if you just happen to get sick one day, that there are resources available to you. If I notice that a lot of people are not showing up to class because they're just watching the echo recordings, I will stop posting the echo recordings. Okay? But I want you to know that that's there. And on that note, one other thing I should say, so if you click in there, you'll see it loads up. One thing that you notice is already here, this is sort of a sad thing. I will not be here on Thursday. I'll send out an email to all of you about this after class. I've had a family emergency come up in the last couple days, and I will not be here on Thursday. I will not have email access most of this weekend. And so what that means is, number one, David will actually be covering the lecture on Thursday. I apologize that I will not be here, but my presence is needed at home. And if you have any questions about anything, again, use the Blackboard discussion forums this weekend. The TAs will be monitoring it. And if you have personal questions, you can email them to me, but know that you will probably not get a response until next week. You'll find as the semester goes on, I'm usually pretty good about responding to emails, but this week is going to be a bit weird. So I appreciate in advance your understanding with that, and I apologize that it happened so soon, but you don't always get to pick when there are issues. Well, one of the things I've done for that is I've posted the video from last term's lecture. If you want to see how I would have covered the material, David's using the same slides that I would, but we all put our own sort of personal thumbprint on it. That's there for you to reference. Just note, as I mentioned, sometimes the echo system doesn't work. This was one of those days where it decided, oh, I don't want to capture the computer. So you can get a nice video of the screen that's sort of hard to read, and you can hear what I was saying. But I want that resource there for you. And like I said, I apologize that I won't be here with you on Thursday. Anyway, so questions before we do something else? All right. So if we go into this, I wanted to spend today, at least this little bit of time, sort of talking about, what is applied mathematics. So we have this course, Applied Math in Modern Technology. How many of you know what modern technology is? Okay, some hands go up. What's a modern technology? If you're completely drawing a blank, there are 7 of them listed on the syllabus. Okay, so I see someone waving their cell phone at me. Is that a modern technology? Sure. What's another modern technology? I'm sorry? Applications on your phone. Right, so the programs on your phone and all of the software that's running, that's a modern technology. I see several people have their computers out. Is that their laptops? Is that a modern technology? Yeah. Can you think of some others? What are some other modern technologies? Okay, tablets. So we're lots of computers. So if you look at the syllabus, what you'll see is sort of units 2, 3, and 4 are labeled digital devices. What that means is cell phones, computers, tablets, a lot of their underlying functionality is quite similar, and we'll talk about that when we get to those units. But those are absolutely modern technologies. So we have a pretty good handle on what's that. What is applied mathematics? If we're going to be talking about applied math and modern technology, we sort of need to know, what are those two sides? If I asked you, what is applied mathematics, what would you say? It's mathematics that's applied. Surprisingly, not a bad answer. Okay. So what I want to do today is focus on that question. What is applied math? And so I've posted a few things here to Blackboard. One is new this semester. There's a video I found on YouTube a few days ago.
The mathematics we learn in school doesn't quite do the...
Pause this. We're not going to watch the whole thing, but I encourage you to do so on your own time. Basically, what he calls this map of mathematics, sort of going through what are all these different areas of math, and at a very sort of high level, what were they designed for, and maybe what do they do? And so if you haven't looked at a lot of math, or you're not really a person who says math is my thing, and that's fine, I recognize no one's perfect. That was a joke. Okay. There's some really neat information. There's some nice narration, and he has a wonderful British accent. Okay, but there's the video there if you want to see. What I've got posted more here is sort of for this big picture, there is this compendium, I'll call it a tome, of this thing called the Princeton Companion to Applied Mathematics. You can see this is a massive, massive book. Do not go buy this. You will not need it for this class. But the idea is to answer what is applied mathematics. This basically gives like a 5-page summary on most topics that people would consider applied mathematics. This is not a thin book. I mean, this has at least 15 pages in it, right? So there's at least 3 things that are applied math. A lot of that book is well beyond what we need for this class, but there were some neat things early on in it. And I've posted a few pages from the very, very, very beginning of this book where it says, Part 1, Introduction to Applied Mathematics, 1.1. What is applied mathematics? This is written by Nicholas J. Hyham, who's a very, very, very highly respected linear algebra and numerical methods person from England. So I will let you read this on your own time, but what I want to point out is there's this wonderful little quote here by Prager dating back about 45 years where we say, and I will not make a habit of reading to you off the slides as this semester goes on, but today is going to be sort of one exception for the next 30 seconds. Precisely to define applied mathematics is next to impossible. It cannot be done in terms of subject matter, the borderline between theory and application, so between what is pure math, just looking at numbers and equations for the sake of looking at numbers and equations, versus an application where we actually solve real problems with it, is highly subjective and shifts with time. Nor can it be done in terms of motivation, where you say to study a mathematical problem for its own sake is surely not the exclusive privilege of pure mathematicians. Okay? So just because we don't have an application doesn't mean it can't be applied math. Perhaps the best I can do within the framework of this talk is to describe applied mathematics as the bridge connecting pure mathematics with science and technology. Applied math and modern technology. Well, that seems like a peanut butter and jelly sandwich. Those two just go together. Unless you're allergic to peanut butter, then don't do that. Okay? And so to focus a little bit more on this last part, describe applied mathematics as the bridge connecting pure mathematics with science and technology. So pure mathematics, these are tools. These are things, how many of you love the quadratic formula? Okay, one hand shot up. Okay, a few hands less emphatically. Okay, so that's something from pure mathematics. And what does the quadratic formula do? Yeah. Okay, it factors. It finds the roots of that parabola. Okay, so that sounds already kind of technical, and that's really starting to sound mathy, right? Okay, so the quadratic equation, that's something sort of like pure mathematics. Or is that science and technology? It's pure mathematics. Okay, but do we find uses for the quadratic equation? Yes. Okay, so we can actually find that the pure mathematics is this tool set. What are all of these things available to us to help us solve problems? And then when we look at science and technology, in this class focusing more on the technology, we find real-world problems that can be addressed using those pure mathematical tools. So what I want to do here is talk about a little example. This came from the book. I apologize, I forgot to bring my version this morning. Things have been a little bit frantic the last couple days. Called How Not to Be Wrong by Jordan Ellenberg. It occurs at the very, very beginning of the book. And it goes back to a story dating back to World War II. So how many of you have heard of the Manhattan Project? Okay, most hands go up. What was the Manhattan Project? Okay, we'll talk about that more when I think it's the data storage unit here in about 3 weeks. We'll come back to that point. Where did the Manhattan Project take place? This is a trick question. It was not Manhattan. Okay, we'll answer that question again in a couple weeks. But anyway, the point here is the Manhattan Project was not actually in Manhattan. It turns out there was a different group of people that were approached by the United States government to help with the war effort that actually were in Manhattan. Basically, the building they were in is now owned by Columbia. It wasn't at the time. But the US government, and the military specifically, had some issues that they wanted worked out regarding aircraft in the European theater of World War II. And so they assembled what they called the Statistics Working Group, which is probably the best group of statisticians that has ever been assembled in the history of human civilization, in 1944 and 1945, to address some of these questions. And they actually met in Manhattan. So from a geographic perspective, they were the Manhattan Project. Okay. But the idea here is that the military had aircraft that they were using in the war. Everyone can believe that aircraft were used in World War II, right? Okay. And it turns out when they would fly the aircraft over hostile territories, specifically the European theater, that people on the ground or from other aircraft would shoot at them. Okay, everybody's still with me thinking this is a believable story? Okay. So it turns out when you shoot an aircraft, sometimes it damages the aircraft. Okay. So the military came to these statisticians and said, you know, we can fortify our aircraft. We can put some extra material on the aircraft. We can add armor that makes them more resilient to enemy gunfire. But the question was, anybody want to guess, what's the question the military wanted to know the answer to?
How much?
Right, so, well, that wasn't the exact question, but it's on the right track. So your question was, how much armor can we put on so it still flies? They knew exactly how much. Okay, because adding armor is heavy. If you make the plane too heavy, it doesn't fly. And you no longer have an aircraft, you have a very bad car. Okay, so there's a certain limit to how much armor we can put on. So the question they wanted to know is, how much armor do we need and where do we put it? Exactly. And so they came up to these statisticians and asked this question. Okay, so thinking about our quote here on applied math and technology, do we have some sort of real-world application, some science and technology? Yeah, government absolutely came with that. Do we have the mathematics to address it? Yeah, we do. Okay, so we're starting to see how this all works. So they go to the statistics research group, and they say, that's a great question, but we need a little bit more information. What's some information, if you were presented with that question, where should we put this armor on the aircraft to make it more resilient to enemy gunfire? What's a follow-up question you might ask? Do you have enough information to address that question? Would you randomly guess, put it on the propeller? What might you want to know? Right, okay, so statistically speaking, what parts of the airplane are getting shot most? Yeah.
Which parts get shot at cause the most damage?
Okay, which parts, when they get shot at, cause the most damage? Great question. Can you think of other questions that you might want to ask the military before you give them an answer? Remember, this is the military. If you give them a bad answer, you're going to find yourself in the European theater of the war. Joke. My grandfather fought in the Pacific. I can joke about the European part. Okay. Anyway, so you're exactly along the right lines. They asked the military, can you give us more information? What happens to different parts of the plane? And the specific information that they asked for was, what's sort of the density of gunfire, of bullet holes that come back? So the military goes to the European theater, and they start auditing and inspecting airplanes when they come back from the active theater of the war. And they start looking at different parts of the plane and assessing how many bullet holes were there, how much gunfire did that part of the plane see. And so they come up with a table where we'll have what's the section of the plane, and we had the density of bullet holes. And this was given in holes per square foot. That's a dividing line. And so they come back, and one section of the plane that the military had looked at was the engine. Okay. That's probably a reasonably important part of the plane. Okay. And the bullet hole density that the military measured was about 1.11 bullet holes per square foot. Okay, so it's about one bullet hole per square foot. They also looked at the fuselage of the plane and found that it took quite a bit more of a beating and got about, almost 2 bullets per square foot. They looked at the fuel system, also probably a fairly important part of the plane. Somewhere in between, right around 1.5 bullets per square foot. And then, as is the military's favorite, we had a catch-all for the other parts of the plane. And that got the most, that had 1.8 bullets per square foot. So the military and the government comes back to the statistics research group with this information and says, okay, great, we've given you this information, where do we put the armor? Okay, so I'm going to ask you the same question right now. Where would you put the armor? I'll give you a moment to, 10 seconds, let's look over this. We'll take a show of hands here in a moment for what you would pick. Okay, so what about the engine? How many of you think you'd put the armor on the engine? Okay, there's a couple of hands that go up. How many of you would put your armor on the fuselage? Okay, a few more hands go up. How many for the fuel system? Okay, about the same number of hands as the engine. And how many of you pick other? Okay, that's probably the most hands. So someone who picked other, why did you pick other? Anyone? This is going to go a lot easier if you volunteer something. Yep. Right, because it had the highest density. Most of the bullet holes were in the other section, so that's where the plane is getting hit the most, so maybe that's where we put the armor. Okay, seems like a completely reasonable conclusion. How many of you, someone who picked fuel system, why did you pick fuel system? Because you like the third option? You've always been told in a multiple choice test, pick C? Okay. I guess in this case that would work.
I have a question.
Yes, question.
These planes came back and got audited. Did the planes fly back, or were they like kind of
Haha. Okay, so the question was the planes that got audited, did they fly back or were they somehow retrieved by other means? Can we hold on to that question?
Okay.
We'll come back to that in about 60 seconds. Okay. So anyone who, yep.
It's a pretty vital part of the plane, and it has a high density.
Okay, so you picked the fuel system because it's a pretty vital part of the plane. If the fuel system goes down, so is the plane. And it has a pretty high bullet density. Okay, sure, that's reasonable. Anyone pick fuselage? Why did you pick fuselage? Anyone? Or have people changed their mind and anyone who said fuselage no longer wants to say fuselage?
If the planes came back and they didn't fly back, I would pick engine.
Okay, so if the planes flew back and didn't come back, you'd pick engine. Okay, because engine had the lowest bullet holes. So it turns out the two answers that the statistic research group came up with, and it was not a unanimous decision, was they said other and engine. Okay, and so they said put it in the other places because that's where most of the bullets are. And all but one person in the room said other. That's where the most bullets are. The data says you should put the armor there. The one person who dissented from the opinion said engine. Everyone in the room, and I apologize, I forget the names involved. The one who dissented was pretty much everyone agreed, the smartest man in the room. And there were a lot of smart people in that room. So let me just put that in context. Interestingly, he was also not an American, and so he wasn't actually shown what the labels were. He was just given numbers and said, which one do you pick? Because the military didn't trust him. He's a spy. He was not. Okay? But he says engine. And everyone looks at him and says, well, you're crazy. The engine has the lowest bullet holes per square foot. Why would you choose the engine? And the reason is?
Because it takes the lowest amount of bullets. Basically, it has the lowest capacity of taking bullets before it actually stops working.
Right, okay. So I'll reiterate that as we sort of work through this discussion. The idea being there was a key assumption that everyone made. The military came back with these numbers and said, these are the bullet hole densities. When the plane comes back and we can audit it, this is what we find. And the assumption that was made was that the planes that return are representative of all planes. Okay, so if every plane we knew was going to come back, then you would probably want to put the armor around other. But the issue is, did every plane that went out into the theater and got fired at, did it come back? No, it didn't. And so what this data is actually suggesting, of planes that come back, very few of them are shot in the engine, which would imply that planes that get shot in the engine don't come back. So where do you put the armor? Around the engine. That's still not a guarantee, it's not foolproof. But this is the style of critical thinking and the style of analysis we want to get at in AMS 103. How did we go from here's sort of this technology that we can study and we can understand, how can we bring in a little bit of mathematical tools and try to answer some real questions about that technology or its use or its applications and so on. So this is sort of, a 10-minute case study on what we're going to do. And so the way that this is going to work as we go throughout the semester is basically following some sort of flow where this is not an ironclad rule and there will be some variability from unit to unit, but what we're basically going to do for each unit is start off by spending more or less one lecture discussing the technology. And again, the idea there is, what is the history of this technology? Most of these things weren't invented by accident. Okay? In some cases, we'll talk about some legal issues. Okay? Because can there sometimes be legal issues with technologies? Yeah. Okay? Along those lines, one of the units that we get into later, how many of you have ever read an act of Congress? Okay, one hand went up. Two hands went up. We're going to actually take a look at an act of Congress when we get into this term. This will be after spring break. It's only about a page and a half long. It's all of 3 paragraphs, and most of it's legalese, but it's a pretty simple and straightforward law. But there can be legal interpretations and ramifications for different technologies, where sometimes it takes the law decades to catch up with what technology has done. That happens sometimes. Okay? But we can do that. We'll talk about some societal contexts. We'll talk about, like I said, history. We'll talk about other applications. But the idea is to really understand what is the technology and what is it trying to do. Okay? And so we'll spend a little bit of time doing that. Once we've done that, where we're basically going to head, and this is sort of the key thing to keep in mind on any unit, is we're going to come up with on what are, in my slides, all labeled as a driving question. So we're going to develop a driving question. And what this is going to do is provide the focus for our unit. So we start off with what's the technology and what's that context. And we're going to arrive at one question, maybe two, related to that technology. That's then going to help us focus how do we get into the math and how do we actually do something tangible related to that technology. We'll develop our first driving question next time in lecture. But that sort of is the focal point of the unit that then links the two parts. How do we get from the math and the technology to the math, math to technology? Our driving question in our example, where do we put the armor? Okay, so we talked about the planes, we talked about that historical context, a little bit about this is fighting a war in World War II and all of that, and we arrived at that question. And was that question something math could help with? Sure. And a little bit of critical thinking. That's the idea. Once we do that, usually we'll introduce a few math concepts. Related to answering that question. This might be a little abstract, but we'll try to keep it fun as the term goes on. And then at the very end, we're going to apply those math concepts to the technology via the driving question. Go away. Happy Monday. I recognize it's Tuesday. Okay, so that's going to be the main theme, and as we go through the units, we're basically going to be going through these 4 steps. Like I said, there'll be a little bit of variability, but... So the homework questions are going to look at probably all sorts of elements. Some of the homework questions will be more in line with what's the technology, and are going to just require like written short answer things. Others will be more focused on the math concepts, so asking you to do simple things, and there's usually one problem that sort of links them together, which is usually one of the harder problems. I want to give you the note right now. You know, these units are fairly independent. Recognizing that most courses you're involved in, sort of the beginning of the semester is fairly light and things get more complicated as we go through the semester and things get harder when you get towards the back end. I intentionally start AMS 103 the other way around. The first unit that we start next week on GPS, or next lecture on GPS, historically speaking is probably the hardest unit in the class. So we're going to get that one out of the way while all of your other classes are sort of on low intensity, and we're going to sort of then come down from there as the term goes on. That way it sort of balances with the other semesters. So if you're looking at lecture on Thursday and next Tuesday and thinking, whoa, 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 this is way more than I signed up for, that is the hardest unit in the course, in my opinion. I don't know, Margaret. It's up there. There are certainly easier ones than the GPS unit. Okay, so just keep that in mind. So then, are there any questions about this sort of intro and overview this morning? If not, then what I would do is I have a survey just where I would like to get to know a little bit more about you. You can express your preference on when you might want homeworks due. And then also if there are some technologies that you think would be really fun to discuss, I'm always looking for new ideas and new units. I would love to hear what you have to say. So I will distribute these to the room. Please fill one out and just bring it up. Otherwise, that's it for today. Again, David will be here running lecture on Thursday, and I will see you next Tuesday. Thank you for your attention today. Have a wonderful afternoon, and I'm really looking forward to working with you this term.